Assalamualaikum warahmatullahi wabarakatuh. So now moving on, we have looked into how to solve the linear equations. Okay, and then from this form, from this form of equation, then we can get a general or a complete solution, and that general or complete solution is a combination of a particular solution and a special solutions. And then we have known how to get that by using these three steps. And then if let's say we get a complex or complicated system of linear equation, then the next part is we need to reduce it, and we can reduce it by using Gaussian elimination. And this Gaussian elimination can be used can be applied by using these three operations: exchange, multiplication, and addition of the rows. And then now we will look into the what is row echelon form. So a matrix is in row echelon form if all rows that contain only zeros are at the bottom of the matrix. So the example is, if let's say you get this matrix, okay, so if you look into these examples here, you can say that all rows contain only zeros are at the bottom of the matrix. Correspondingly, all rows that contain at least one non-zero elements are on top of rows that contain only zeros. Like this one, this number 1, it is non-zero, and the location for this non-zero is on top of the zeros. Looking at the non-zero rows only, the first non-zero number from the left, okay, from the left is called the pivot. This is, we call it as pivot. This also we call it as pivot. It's always strictly to the right of the pivot of the row above it. So this, if you focus on the second row here, this is the pivot for the second row, and this pivot is strictly on the right of the first pivot on the first row. Okay, right. So what is a basic and free variable? So by having the row echelon form, we can identify what is basic and what is a free variable. So in this case, okay, in this example, okay, if you translate if you extract the A matrix from this equation, then you will get 1 minus 2, 1 minus 1, 1, and then 0, 0, 1, minus 1, 3, 0, 0, 0, 1, minus 2, 0. Okay, so this is the A matrices. So from these A matrices, which one is the pivot? Okay, so the pivot for the first row is number 1. What about the second row? It is in 1, the x3. And then what about the third row? It is also 1. What about the last row? There is no. Okay, it is none. So in this case, okay, we know that the first column present for the x1. This one is the x2. This one is the x3. This one is the x4. This one is for the x5. How we know that the first column is for x1? Because if we have our x1, x2, x3, x4, x5 here, okay, remember this matrix is actually in this form, right? So when we do the multiplication, then the first column will be multiplied with x1. The second column will be multiplied with x2. The third column will be multiplied with x3. The fourth column will be multiplied with x4. And the fifth column will be multiplied with x5. So that is, by having that, then automatically we know that the first column present the xi. Okay, the xi. Alright. Okay, so from back to these definitions here, so we can know that the basic for this equation is x1. The basic is x1. Okay, x3 and x4. Okay, so the pivot is the basic variable. So pivot variable is equivalent to basic variable. What about x2 and x5? x2 and x5 is our free variable. So when you want to solve this equation, then the x2 and the x5 can be any numbers. Can be any real numbers. Okay? Alright. So this is basically the technique to obtain the particular solutions. So the first way just now, we can just use the simpler form from the matrix as in this example. Okay, and this is another way. So to obtain a particular solution, the row echelon form makes our life easier where we need to determine a particular solution. To do this, we express the right hand side of the equation system using the pivot column such that B is equivalent to this. B is equivalent to the summation I equal to 1 until P, and then we multiply the lambda I with the PI. Okay, where PI is I equal to 1 until P are the pivot columns. Okay, and the lambda I are determined easiest if we start the rightmost pivot column and our work way to the left. In the previous example, we would try to find the lambda 1, lambda 2, lambda 3 so that the lambda 1, 100 plus this, we will get this one. From here, we find relatively directly that lambda 3 is equal to 1, lambda 2 is equal to minus 1, and lambda 1 is equal to 2. When we put together, we must not forget the non-pivot column for which we set the coefficient explicitly to 0. Therefore, we get the particular solution x equal to here. So this is the easiest way to get the particular solution. Alright. 20 minus 1, 1, 0. Yes, 20 minus 1, 1, 0. Okay. So this is the easy part. Okay, to get the particular solution. Or you also can use the inspection approach as mentioned in the beginning. Okay, so Gaussian elimination is an algorithm that performs elementary transformation to bring a system of linear into reduced row echelon form. So verify that the following is in a reduced row echelon form. So the pivot are in bold. Okay, so this is just the way on how to verify whether this is the row echelon or not. So from here, you can try to get the solution. Okay, so this is also some trick actually to get the row echelon. So you can try to have a look at this by your own. And this is also the example which I will leave it to you to solve this. Alright. And this is also a way we can also get the inverse matrix by using Gaussian elimination. Okay, so to get this one, remember for the matrix, okay, matrix, we know that the multiplications of A with the A inverse, we will get identity. So, by using a Gaussian elimination approach, the B side here is the identity matrix. So you repeat the approach by using the Gaussian elimination, then you strictly can get the inverse matrix. Okay. Alright, I will stop here. Thank you.